Podemos iniciar. ¿Es la hora ya, Rodrigo? Es que yo como tengo la pantalla compartida no veo.
57, vea.
57 y vea. Ya, sí, pueden iniciar lo de YouTube mientras, y a las 8 yo empiezo a hablar y así ya puede empezar Carolyn a tiempo, ¿vale?
Llegó un mensaje que está en live now.
Muy bien.
Pero no lo veo en YouTube.
Ah, pues entonces empezar ahora. Yo empiezo a hablar a las 8, pero quedan 2 minutos, ¿no?
Sí, 2 minutos.
Vale. No lo veo yo tampoco en YouTube, ¿eh? Voy de nuevo por si acaso.
We can start, Bea. Go ahead.
Ok. Bienvenidos todas y todos a esta 24ª edición de la Conferencia Iberoamericana de Ingeniería de Software CIPSE. Estamos muy felices de tenerlos aquí, de compartir con ustedes esta semana rica de investigación en ingeniería de software. Mi nombre es Beatriz Marín y junto a Rodrigo Fonseca somos los chairs. Somos los chairs de ElBAIS, la Escuela Avanzada de Ingeniería de Software. Estamos muy felices de poder compartir con ustedes esta semana y dar este puntapié inicial a CIPSE 2021. En la Escuela Avanzada de Ingeniería de Software este año tenemos a 3 conferencistas, 3 speakers. Estamos muy agradecidos de poder contar con ellos. Primero con el doctor Luis Olcina, de la Universidad Nacional de La Pampa, que nos va a hablar de ontologías. El doctor Oscar Dieste, de la Universidad Politécnica de Madrid, que nos va a hablar de análisis de potencia en los experimentos. Y la doctora Carolyn Seaman, de la Universidad de Maryland, Baltimore Country, que nos va a hablar de la deuda técnica. Como ustedes saben, en esta conferencia nosotros potenciamos el lenguaje, la lengua materna. Entonces la conferencia es en español, mi lengua materna, en portugués y en inglés. Estos tracks, estos tutoriales van a ser a la 1 CMT-6, hora de Costa Rica, el tutorial de Luis Olcina, a las 10 el tutorial de Oscar Dieste y ahora mismo el tutorial de Carolyn Seaman. Ahora voy a hablar en inglés. Welcome to everybody to this 24th Ibero-American Conference of Software Engineering CIPSE. We are happy to start this conference with the Advanced School of Software Engineering ElBAIS. Me, Beatriz Marín, and Rodrigo Fonseca are the chairs of this advanced school. And we have 3 tutorial speakers for today, and we will start with Carolyn Seaman. She's professor of the Maryland Baltimore Country University. I'm really glad because she's also the director of the Women in Technology Center. And she works, the research area she works is the empirical software engineering. Specifically, she works on maintainability, communication, and technical debt. So today we are really happy to announce that Carolyn Seaman will delight us with the important role of the technical debt. So Carolyn, start when you want, and welcome everybody to CIPSE.
Thank you very much. I'll share my slides. All right, here we go. Right, buenos dias, bom dia, good morning, everyone. Muchas gracias and muito obrigada. Thank you, Bea, for the introduction. My name is Carolyn Seaman. I'm going to be talking today about technical debt and decision-making. But I also want to acknowledge two of my current and recent PhD students, Abdallah Adij and Yupugwo, both of whom have done extensive research in this area, and their work makes up an important part of this tutorial. So many, many thanks to both of them. All right, just as an overview of what I'm going to talk about, in case you want to decide not to listen to the rest of it, this is the whole idea. Technical debt, and I'll explain in more depth what technical debt is, but the central idea of technical debt is about trade-offs between short-term gains or short-term benefits, good things that happen soon, and long-term costs. So costs or disadvantages or things you need to pay for in the future. So decision-making related to technical debt is all about trying to maximize the value of that trade-off. But if you open the view a little bit bigger, if you widen your lens, throughout the software development lifecycle, decisions are made based on trade-offs. It's something very common in software projects. Decisions about which features to implement next involves a trade-off between short-term gains and long-term costs. Which architecture is best? The one that's quickest or the one that provides you a better architecture in the future? How much to test or when to stop testing? That's clearly a trade-off between short and long-term. And when to invest in process, that's another one. So there are all these decisions that are made in a software development project, and they all have this core similarity about this trade-off between short-term and long-term. And technical debt decisions are one example of that, a good example of those types of decisions. So my argument in this talk, in this tutorial, is that if we better understand technical debt decision-making, and we look at the research so far on technical debt decision-making, that will tell us a lot that we can apply to improving decision-making throughout the system, the software development lifecycle. So I'm going to start by explaining what technical debt is, some basics about technical debt and current research on it. And then I'll focus in on the role of decision-making in managing technical debt and talk about some of the current research in technical debt decision-making. And then again, I'm going to widen the lens a little bit and look more broadly at software development in general and the role of decision-making, and then tie the two together. So I'll be looking at what we've learned about technical debt decision-making and talking about what we can learn from that to other types of decisions in software development. Okay, so we're going to start off by talking a little bit about what technical debt is. So the context in which we're talking about technical debt is software maintenance, okay? So imagine yourself, and many of you don't have to imagine very far, right? You're already in this context of maintaining a large set of systems, big old systems that need to be maintained. They need to be fixed because they have problems. They need to be enhanced to make them continue to be useful. They need to be adapted to new environments. And these systems, these big old systems, need constant modification in order to make them remain useful. And they're too expensive to replace. So a lot of money, a lot of time, a lot of resources go into maintaining them. But maintenance, even more than development, is constrained by tight budget and time constraints. But usually in most organizations, the business model does not favor lots of time and resources for maintenance. Okay, so tight budget, tight time constraints, that's the context in software maintenance, and that's the context in which we're talking about technical debt. Okay, so technical debt, what is it? So one way to look at it is it's a gap. Okay, technical debt is a gap. On the one hand, between making a change, these maintenance changes that have to be made to a big old system, making them perfectly, preserving the architectural design, employing all the things that we all learned in university about how to be a good programmer, good programming practices, following all the standards, updating the documentation, doing all the testing that you're supposed to do. Okay, so the gap between doing it perfectly, which no one ever does, but that, and making the change work as quickly as possible with as few resources as possible. Okay, so every once in a while in this talk, in this tutorial, this little green box, green edged box will show up. And this is a question for you. Okay, so I understand you all are on YouTube, you have a chat. I would love to hear from you. Comments, questions, answers to my questions. So to kind of move that along, I have these little green boxes that'll come up every once in a while. And I'll come back in a few minutes to see who put their answer into the chat. And my question here is, who knows what this is? Okay, it's part of the metaphor for technical debt. So hopefully some of you know what that is. So if you do, share that in the chat. Okay, so if you're on a project, if you're working on a software development project that has technical debt, oops, here are some of the things that you might hear on the project, some quotes that you might hear in meetings or on the project team. And some of these are about how fragile the code is, things about putting things off to the future, not doing things right now, but doing it later. And a lot about uncertainty. You know, nobody's quite sure how things work. So some of you might be familiar with some of these phrases, some of these situations, some of these quotes, and these are all everyday indicators of technical debt. All right, in essence, technical debt is a metaphor. It's not a scientific theory. It's not a new theory of the natural order of things. It's a metaphor, okay? It's a linguistic metaphor. So the definition, and it has a number of definitions, but one that I like to use comes from a Dagstuhl seminar in 2016. So Dagstuhl seminars are seminars that happen at this beautiful castle in Germany, where a research group or a group of researchers who are starting a new area in research it's generally having to do with communications or information technology. That group of researchers gets together and they plan out the research agenda for a particular area. So in 2016, there was a Dagstuhl seminar in which we gathered to set the research agenda for technical debt in software. And one of the things we did was come up with a good definition of technical debt. And the definition is here. It says, in software-intensive systems, technical debt is a collection of design or implementation constructs that are expedient in the short term, but set up a technical context that can make future changes more costly or impossible. Technical debt presents an actual or contingent liability whose impact is limited to internal system qualities, primarily maintainability and evolvability. Okay, a lot of words, right? A lot of words, a big mouthful. So let me break that down just a little bit for you. The key part of the definition is that it involves this tension between short-term and long-term, things that are expedient or easier or quicker in the short term, but are going to present some costs later in the long term. Another thing is that it says design or implementation constructs. That means these are things that are close to the source code. Okay, it's not just source code, but things that are close to it. Design documents, testing plans, things that are close to the code. And also it talks about internal system qualities. So these are things that are not visible outside the system. These are things that affect the internal state of the software. Okay. All right. So the technical debt has some benefits, particularly in the short term. Higher software productivity in the current release, and the current release gets out the door faster. And that's why we have technical debt, because it allows things to happen much more quickly in the short term. But there are some costs, what we call interest. Again, this is a metaphor to financial debt, right? When you take out a loan, you take on debt, financial debt in your own personal life or your family or your company. You get a big chunk of money that you can do things with right now, but later you have to pay interest. You have to pay extra money beyond just paying back the principal. So for technical debt, that interest is increased maintenance costs in the future. But there's another cost sometimes, is just like financial debt, sometimes technical debt can get out of control. You can take on so much technical debt that it cannot be paid back, and you have to, the system fails and you have to retire it and start over again. So there is that risk out there beyond just paying back the principal and the interest on the debt. Okay, so it helps sometimes to understand what something is by talking about what it is not. Okay, so here are some things that are not technical debt. Things in general, things that are visible to the user. Okay, so defects are a good example. Defects, and it's easy in the literature, people a lot of times confuse defects, especially minor cosmetic, really annoying little defects, with technical debt. But they're really different things, okay? So defects are visible to the customer. So they have to be fixed in order to satisfy the customer. Technical debt are things that are internal, are not directly visible to the customer, although eventually they will have effects on the customer, but they're not immediately visible to the customer. So defects are not technical debt, but there is something called defect debt. Okay, so it's a little confusing. So defect debt is a type of technical debt, and it's not the defects itself, but it's the effect of having a ton of these little defects that are not immediately important. You don't have to fix them right away, so they get put off and put off and put off for a long time. And you get so many of these little defects over time that it slows down the whole process, and particularly the testing process. So it's that slowdown, it's that effect of this big group of latent defects that we call defect debt. But individual defects are not the same as technical debt. Same with a low quality user interface. A lot of people think that that's technical debt, but that's very visible to the user. So that's really not technical debt either. Staffing issues. So there have been proposals of what's called social debt or people debt, which is a kind of debt. It sort of fits the metaphor, but it's not quite the same thing. So it's not really technical debt. Also process issues, having inadequate processes, not documenting the processes, not following processes. Those are problems, and you might put the term process debt on that, but it's not really a type of technical debt. Okay, so hopefully that helps explain what is and is not technical debt. All right. Oh, and an important point here is all these things that are not technical debt are still things that are important in a software development project, and still things that you have to make decisions about. So remember that. I'm going to come back to that later about decision making about these things that are not technical debt. Okay, so yeah, I wanted to go back. I did have a green box a little bit earlier. Did anybody know what that little picture was? Did anybody put anything in the chat? Or any other questions in the chat? Beatrice, anything there?
Not yet, Caroline.
Oh, okay.
I asked them I remember to answer your question, who knows what this is, how to do it correct, and okay. we don't have answer.
Okay, well, let me go back there just so that everybody learns something today. This is duct tape. Okay, that's what we call it in English. I don't know if it has a different name in Spanish or Portuguese, but duct tape is a very, very strong type of tape. And you can fix anything with duct tape temporarily. It doesn't last forever, but it's something used all over the place to fix things temporarily. So duct tape, that's what that is. Okay, let me go forward a little bit. All right, so, okay, so I want to focus a little bit, still talking about technical debt, but focus on the role of decision-making in technical debt. All right. So there are sort of two ways to manage technical debt. You can manage it implicitly or you can manage it explicitly. So managing technical debt implicitly means that you do it without really thinking explicitly about technical debt. So the way this works sometimes looks something like this. So say there's a developer, David. David is a developer, and David's manager is Maria. Okay. And say David has been given a maintenance task to do. He has to make a change to some source code, and he's looking at this source code, and he's thinking this source code is really bad. This is going to be very painful to make this change. This looks horrible. It's going to take me a long time, and it's going to be really expensive to make this change. So he decides to talk to Maria about it. And he says, Maria, I really think we need to spend some time refactoring this module in the next release before we start making changes to it. We need to do refactoring. And Maria says, well, why would we do that? That doesn't make any sense. That would take time and effort. And, why do we need to refactor? And David says, well, I really think it's going to cause major problems later. He's kind of fuzzy about it, but he thinks, I have this gut feeling. I really think, this is going to cause problems later if we don't refactor it. So Maria says, well, David's pretty smart. He usually knows what's going on. I think I can trust him. Okay, I'll say yes. So she says, okay, we'll put that in the plan for the next release, this refactor. Okay, so what David is doing here is he's recognizing there's technical debt in this software. He wants to pay back the technical debt by refactoring it, but his manager needs to say, okay, because it's going to take some time to pay back that debt. And so she needs to put it in the plan and she needs to say yes. And she does. She says yes, but it doesn't always go that way, right? So we could have another scenario where we still have David, we still have Maria. David is still looking at this horrible code and thinking about making a change to it and thinking that it needs to be refactored. So he asks Maria, can we refactor this in the next release? And this time she thinks, these developers, they're so annoying. They always want to make the code absolutely perfect. I need some evidence that this is a good idea to refactor. So she asks David, what's the ROI, the return on investment? What's the ROI of this refactoring? And David, who's a developer and doesn't know a lot about ROI, right? And he says, what are you talking about? And she says, no, we'll stick with the important features. We're not going to put the refactoring in the plan. Okay. So my point here is that this is managing technical debt implicitly. Nobody's using the word technical debt here. Maria doesn't understand about technical debt, but she's making these decisions based on how she feels about David, basically whether she trusts him or not. So managing technical debt explicitly would give her a better basis for making those decisions. Okay, so explicitly managing technical debt, there's been a lot of research, a lot of proposals about how to do this, but it means taking steps and gathering information in order to make a good decision about whether to incur technical debt or whether to pay off technical debt. And usually explicitly managing technical debt revolves around something called a technical debt list. And this list takes many different forms. Sometimes it's part of the project backlog. Sometimes it's a separate thing. I'm going to tell a little story actually about the TD list. And this was many years ago when I first was introduced to the topic or the concept of technical debt. I was meeting with a set of developers and I was actually doing a completely different research project with them on a different topic. But they started talking about technical debt and I didn't know what it was. So I asked them, I said, what is this technical debt thing? So they explained to me the general idea. And then they started pulling out these pieces of paper. So they would have these pieces of paper hidden underneath their keyboard or taped to the side of their monitors or somewhere. They'd have these pieces of paper that were very messy. They were crumpled. They were sometimes torn. They had things written on them and scratched out. And they showed me these lists, these pieces of paper, and had lists of things that they wanted to do to the code when they had more time. Okay. And this was their TD list. And they sometimes called it a technical debt list, but more often it was their to-do list. Okay. Things that they wanted to do when they had time. And the problem was they never had time. So these lists were very old. These pieces of paper had been around for a very long time, but that was how each individual developer managed their technical debt. because there was no way to do it at the project level. None of the managers understood technical debt. The developers didn't even try to explain it. They tried just whenever they could find time, they would look at their TD list and do something, refactoring or fixing something or something that they knew would make the code more maintainable. Okay, so when you're explicitly managing technical debt, you have a better TD list. Okay, you have a TD list for the project. It's usually not on paper, it's in some sort of electronic form. And there are three basic activities. There's technical debt identification, where you put stuff on the list, and you can do that in a variety of ways. A lot of times developers just know where the technical debt is and they put it on the list. Sometimes source code analysis tools are used to find pieces of code that don't conform to standards or that have problems. Then there's TD estimation, where you try to estimate, and this is done in different ways. Often you're estimating the amount of work to pay off the technical debt. Sometimes people try to estimate the impact of not paying off the technical debt. Sometimes things are measured just to figure out how much technical debt there is. So this TD estimation is an effort to quantify different aspects of technical debt. But both of those, TD identification and TD estimation, are all about gathering information that's needed for decision-making, which is really at the core of managing technical debt, is making decisions. So that's what I'm going to focus on now. Okay, but before I go to that, I want to talk a little bit about payoffs, because sometimes, you don't really need to, or the argument is made that you don't really need to explicitly manage TD, that the way Maria is doing it, just making these decisions on the fly, that's good enough. But there are some payoffs of actually spending some time and energy in identifying, documenting, and estimating technical debt so you can make good decisions. And the big one is lowered maintenance costs. So those long-term costs of technical debt can be managed, can be kept to a minimum if you're explicitly managing TD, those interest payments. At the same time, you don't want to pay off too much technical debt, because not all technical debt has to be paid off, but you need to do some explicit management in order to figure that out and make good decisions. You have better productivity during maintenance because you have better prioritization of tasks. You know which tasks are the most important, when it's the right time to pay off technical debt and when it's not. And the code is easier to work with if it doesn't have a lot of technical debt in it, if it's not ugly code. And the big one, and this is true of any kind of explicit management of any aspect of software development, is avoiding surprises. If you're not keeping an eye on the technical debt, it tends to grow invisibly. Everything about software is invisible, right? And technical debt is also invisible unless you're looking for it. So if it's invisible, it can build up over time, and you have unexpected failures that are really hard to figure out the reason for the failure if it's due to technical debt. Sometimes you have a maintenance task that is way, way more expensive than you expected because of technical debt. And it basically, you have better predictability. You can better estimate the costs and risks of those of those maintenance tasks. But all of this requires really good decision-making, not only just gathering the information that you need to make the decision, but also the process for making that decision. Here's another green box for you to put an answer to the chat. Can you think of other payoffs, other advantages of explicitly managing technical debt? So think about that for a minute. If you have an idea, put it in the chat. Okay, so I'm going to switch gears a little bit.
Dear Caroline, we have a question here.
Yeah.
Yeah, it's talking about the implicity of technical debt management, is from Cecilia Apa. So she says, do you think that adopt technical debt management or not systematic technical debt management in some way implicitly? It's implicit also? What do you think?
Can you say that again? Is what implicit? What?
Do you think that there is adopt technical debt management or implicit, non-systematic technical debt management in some way implicit?
Right. So I think it's a continuum. It's not black and white. It's not either all implicit or all explicit. There's lots of things in between. So some parts of technical debt management could be implicit. For example, identifying technical debt could be very implicit. You could just rely on those pieces of paper that the developers have under their keyboards, and that could be your technical debt list. You don't necessarily need to have tools and heavyweight processes to identify the technical debt. It could be very implicit, just based on what developers feel. But then if you put that technical debt into a common list and you explicitly prioritize them based on defined criteria, that's explicit management. So that has advantages, okay? So there's an implicit part and an explicit part. So that it doesn't have to be all one or the other. Does that answer the question? I'm not sure I completely understand the question, but does that make sense?
Yes, if I understand that you answered the question. Let's see what says Cecilia in the chat.
Yes, right. Cecilia, if I didn't answer your question, please ask again and let me know. I'm happy to say more. Okay, anything else from the chat? No, okay. Okay, thanks. All right. So what I'd like to do now is talk a little bit about research and technical debt decision-making, some things that we have learned and some things that we've looked at, okay? And here this, I'm relying very much on my student Abdallah Al-Daij and his literature review that he wrote for his dissertation. His dissertation is all about technical debt decision-making, and he did a great literature review, so I'm borrowing heavily from that. Thank you very much, Abdallah, for letting me steal your analysis. So if you look at the literature on TD, technical debt decision-making, there's really, you don't find much at all before 2012, okay? So 2010 is sort of marked as the beginning of technical debt research, because that was the first workshop on technical debt that happened in 2010, and that has happened every year since then. But it took a while. For a while, most of the research was focused on identifying technical debt. But in 2012, people started looking at technical debt decision-making, and we called that era up until 2018 hypothesis-driven research. That basically means that people were proposing ways to make better technical debt decisions. So it was a lot of proposals, a lot of new approaches, new tools for making technical debt decisions. In 2018, it pivoted a bit. We started spending more time studying technical debt in practice. So looking at what projects were doing to manage technical debt and to make technical debt decisions in practice. So there was sort of this pivot around 2018, which was not very long ago, just a few years ago. So there's not a huge amount of research done in this area, but I'm going to talk about these two different areas of research separately. Okay, so hypothesis-driven research, which we first started seeing about 2012, were where a researcher would develop a tool or a technique, and in theory, they would evaluate it in practice. Well, part of the problem with this literature is that evaluation in practice did not happen very often. Mostly it was just a proposal, maybe some sort of evaluation of the proposal, but not really trying it out in practice. And this is because this area was so new, and it was hard to find projects in industry that were already explicitly managing technical debt, or were even interested in explicitly managing technical debt. So it was difficult to do research in the real world settings back in 2012, 13, 14. So there were a lot of these proposals, and that's what we're calling the hypothesis. The hypothesis was that this proposed approach would work, it would support technical debt decision-making, it would result in better technical debt decisions. And most of these proposals, these proposed tools and techniques, fell into three areas. One was measuring technical debt, prioritizing technical debt, and visualizing technical debt. So most of this, because it was in these three areas, were not really about the decision-making process itself. They were about gathering the information that a person needed to make good decisions about technical debt. Okay, so this literature before 2018 had some limitations, okay, not validated in practice, and also not honing in on the actual decision-making process, with some exceptions. So just an overview of some of the approaches that were proposed during that era. There were many variations on a simple cost-benefit analysis. So a cost-benefit analysis is the idea that you balance, you estimate the principal of a technical debt item. Okay, the principal meaning how much time did you save when you incurred this technical debt, versus the interest, some estimate of the interest that you're going to have to pay over time. Okay, and try to balance the principal and the interest and make decisions about which technical debt is good to pay off that way. And there were various variations on that cost-benefit analysis, but much of the literature in this area was about cost-benefit analysis. Some researchers looked at mechanisms or approaches from finance and economics to see if they could be applied. So portfolio management was one of them, where you look at all the technical debt that you have and you try to diversify your portfolio of technical debt so that you have some high risk and some low risk. There's something called AHP, or Analytic Hierarchy Process. AHP is a decision-making process that comes from decision science. And it's about using a group of people to do pairwise comparisons of different options. Then real options, or options, is another technique from finance and economics that looks at the future value of something, which is part of what technical debt is about. You're trying to figure out the future value of something and weigh that against the current costs. So people have talked about different ways to adapt an options approach to finance to technical debt. There have been a couple pieces of work that have looked at optimization functions, so viewed the technical debt decision-making problem as an optimization problem. And then there are a whole lot of visualization techniques that have been proposed that help decision makers understand the information that they have about technical debt. So that's an overview of sort of that first era of technical debt decision-making research up until 2018. So then more recently, in the last 2 or 3 years, we've started to having more research that's exploratory. And this is exploring technical debt from the practitioner's viewpoint, okay? Looking at the causes and effects of technical debt. So asking practitioners through interviews, through surveys, observations, case studies, all those sorts of things that are very direct research methods, asking them what caused technical debt and what are the effects of technical debt. And that leads to the factors that influence decisions, influence practitioners when they're making decisions about incurring or repaying technical debt. So we've learned a bunch of things preliminarily, because this research is still new, but some interesting things that have come up in this set of studies. We've identified 3 types of TD decisions, technical debt decisions. So when I say technical debt decision making, I'm talking about these 3 types of decisions. 1, the decision to incur technical debt or not. That means there's some decision that needs to be made where one of the options will result in more technical debt in the system. Okay. Then there are decisions about paying off technical debt, where there's an opportunity to eliminate some of the technical debt in the system, and whether you want to spend time doing that or not. And then there are also decisions about taking action to prevent technical debt in the future. Okay, so 3 types of decisions. We've learned that the simple cost-benefit approach is not enough. And I'll go into all of these in a little more detail a little bit later. But actually, my former student, Yupa Guo, did a case study about trying to apply just a very straightforward, simple cost-benefit approach to making decisions about paying off technical debt. And it didn't work. It didn't work very well at all for a lot of different reasons. And I'll talk more about that in a little bit. We have identified the main decision factors that people use, that practitioners use when they make decisions. And a little bit later, I'll present a list of those main decision factors. We also found that technical debt is much more likely to be paid off. That is, the decision to pay off, the decision is made to pay off technical debt. It's much more likely if the technical debt is either visible to the customer or or will soon be visible to the customer. That is, it's going to have some effect on the customer, then it's much more likely to be paid off. Sometimes some projects have a lot of success with building in these technical debt decisions into their process, okay, into their build process, into their release process, their sprint planning process or iteration planning process. And when you do that, that takes away the burden on the decision makers, because that means you don't have to make so many decisions. So there are different ways that projects have done that. And with almost everything in software engineering research, everything is highly context dependent. Okay, so what works in one project will not necessarily work in another. Okay, so this is some preliminary results from a fairly small group of studies that have been done in the last 2 or 3 years, where researchers have actually gone in and explored how technical debt decision-making is done in practice. And I'm going to come back to all of these a little bit later. Okay, now I want to talk about software engineering in general. For a few minutes, I'm not going to talk about technical debt. I'm going to talk about decision-making in software engineering, in software projects. Okay, what I'm going to do, excuse me a minute. I'm going to step through a couple of common types of decisions that are made in software projects. Some of them are very low-level, day-to-day project management type of decisions. Others are more high-level strategic decisions. And what I'm going to do for each of these types of decisions, I'm going to talk about how these decisions are based on optimizing a trade-off, some sort of trade-off. And usually it's between something short-term and something long-term. Okay, so short-term goals, long-term goals, short-term benefits, long-term costs, usually. Sometimes it's between the goals of different stakeholders. Okay, so it's not so much a short-term, long-term trade-off, but trade-offs between the goals of developers versus managers versus customers. Okay, and these things are also true about technical debt decisions, TD decisions. So what I'm going to do is make the argument that these other types of decisions are enough like TD decisions that we can apply some of what we know about TD decisions. Okay, so let's try this. I'm going to step through some examples. Okay, the first one, very common, that people do all the time in projects, right, is, I'm trying to catch up with my notes, is prioritizing items in the backlog. Okay, so most projects have something like a backlog. They might not call it a backlog, but it's a list of things that need to be done on the project. The biggest thing on the backlog usually are new features that need to be implemented. Sometimes there are features that have already been partially implemented, but they're incomplete. So incomplete features, work that still needs to be done to implement features. Sometimes there are non-functional requirements that have not been met yet and need some work. Defects that need to be fixed, that's always on the backlog. And a lot of projects also put their technical debt items on the backlog, so paying off technical debt. So prioritizing items in the backlog involves this mix of things and deciding what's going to be done next. Okay, so typically, and this varies, but typically, you maximize the short-term benefit by implementing new features. Okay, you get the most bang for your buck, you get the most bucks, right? The most money from customers by implementing new features. Okay, so if your point of view is maximizing short-term benefit, you want to prioritize the new features. The long-term benefit, however, you gain by paying off technical debt, because if you pay off technical debt, then all the future changes you make will be easier. All right, so that maximizes the long-term benefit. So that's the short-term, long-term trade-off. But there are also different stakeholders here who have different views about what should be prioritized. Typically, customers and managers want you to prioritize new features because they want new stuff. Or if there are major defects, they want those fixed right away because they want to, when they want to please the customers and they want to get more money, they want to sell more products, right? So, so customers and managers have that perspective. Developers often really want to pay off technical debt because their pain is in the code that's hard to work with, right? So their priority is to pay off technical debt. And they also understand better the long-term benefits of paying off technical debt. So this is one type of decision, very common type of decision in a software development project. And it happens constantly with every iteration. You have to make decisions about which things in the backlog are going to happen next. Okay, another type of decision are design decisions. And there are lots of design decisions that are made in a software development project, right? But I'm talking in particular about the high level upfront architecture choices, making decisions about what architecture and what infrastructure you're going to build your product on, build your software application on, okay? And there are some trade-offs here. Convenience, you can choose maybe an architectural framework that already has many of the features built in that will save you some time. It'll be convenient. That kind of choice will also increase your development speed, at least in the short term, because you have good libraries maybe that you can reuse, and building the features of your product will go much more quickly. But you also have to trade off scalability and sustainability. So choosing a particular framework up front might limit your choices later when you want to add new features that you're not thinking about right now, or when you increase the user base or increase the size of the database, or increase other aspects of the software product. An expedient choice up front might limit your choices later. There's always cost. Cost is always an issue. And then there's technical debt. Okay, technical debt is incurred even in these upfront initial architectural choices. Okay, so for these types of decisions, you can maximize the short-term benefit by reusing features or library modules from a framework, okay, or just by using libraries. But you maximize the long-term benefit by doing a full architectural analysis and really choosing an architecture that will serve you in the future, okay? Those two things are very much in contradiction, because reusing something that already exists immediately constrains your choices, but it's much quicker. And taking more time to do the full analysis, of course, takes a lot more time and involves a lot more work because you're building things from scratch. Again, we have stakeholders, we have customers and owners, especially if you're talking about startups. They want a minimum viable product as soon as possible because of money. You know, they can't sell their product unless they have a product. So they want a product as soon as possible. But developers want to avoid the technical debt because they understand how painful it can be later. Okay, so there's that tension. So with design decisions, and this is true to a lesser extent in the lower level design decisions, but the big architectural choices up front are particularly prone to these kinds of issues. Okay, testing. When to stop testing, or how much testing to do, or when to release. The same, two sides of the same decision. Okay, so you're trading off time to market. Okay, you do less testing, you can release earlier, you can get your product out to market, you can start earning money on it. So that's a big consideration. But you're also trading off internal and external quality. If you test less, you run the risk of having a lower quality product, and that's the risk. This is all about risk. And of course, technical debt. Testing debt is a type of technical debt. Testing debt is when you don't test as much as you should have, or your test suite is not adequate. So you incur those types of technical debt if you cut off testing too soon. Okay, so in this case, if you want to maximize the short-term benefit, then you test very, very minimally and you release as soon as possible. So you take lots of shortcuts in testing, and that gets the product out the door faster, which has some benefits. But if you want to maximize the long-term benefit, then you test thoroughly. You do as much testing as possible until you are convinced that the product is as high a quality as possible. Okay. And again, we have stakeholders who want different things. Customers and owners want to release as soon as possible, so they're pushing on testing less, usually. Developers want to avoid having to fix lots of defects later, especially really thorny defects, so they want to find those defects as early as possible. So they want more testing. And testers, of course, because they're testers, they want to do a good job, they want to do a thorough job, so they want to spend some time testing well. Okay, so again, another example of a type of decision that has these types of trade-offs. Okay, one more example. Investing in process, and what I mean by this is developing development processes, documenting them, implementing processes, and assessing those processes And that takes time and resources. So putting in place a good release process and documenting and make sure everybody understands it, putting in place a testing process, a requirements analysis process, all these different processes that have to do, that take place in different parts of the SDLC. It takes time to put those processes in place and make sure that they're working, okay? So how do you decide when and how much to invest in process? So of course you're trading off cost and effort because it takes time, it takes money, it takes resources to put these processes in place. It will also probably slow down your development speed because people are working on process instead of on software. But it should, in theory at least, the whole theory behind having processes, it will increase software quality, at least in the long term. Okay. So of course you maximize short-term benefit by forgetting about process altogether. The short-term benefit is just you rely on your heroes, you get the product out the door as fast as possible. Don't worry about being able to repeat the process, just do it, okay? But the maximizing the long-term benefit is putting high quality processes in place now so that in the future, things are more efficient and higher quality. Okay, short-term, long-term trade-off. And there are stakeholders. So customers usually don't care whether you process or not. That depends though. Some customers do. I don't know about other countries, but in the US, if you're a large government contractor and you develop software products for the government, they have a lot to say about what processes, and they require that they can see what processes the government, that is the government acquisition people, can look at your processes and tell you how to change your processes. But in general, outside the government sphere, most customers don't really care whether you use Scrum or whether you used test first development or whatever. So customers don't care, they just want their product. Managers want to have just the right amount of process. Okay, managers don't like to say that their process is ad hoc. You know, they like to be able to point to, well, we do whatever the latest and greatest process term is, but they don't want you to spend too much time on it. Okay, so managers are always looking for that sweet spot. And developers, same. They don't want to have too much process, but they like to have some process, some discipline. And developers tend to disagree on which processes are most important. So there's a lot of disagreement there. So the conversation among stakeholders tends to be a little messy when it comes to process, but decisions have to be made. Okay, so what do all of these types of decisions have in common? Well, they all involve technical debt, at least implicitly. For most of these, I actually mentioned technical debt. Most of these decisions have the potential to increase technical debt. Some of them have a choice. One of the choice options is to decrease technical debt. And often technical debt is one of the decision factors, at least implicitly. Okay, it's out there, having some influence on the decision making. All these decisions involve money. The short-term benefit usually has to do with money. Sometimes time, but time is really the same thing as money, right? Getting a product into customers' hands means you get money from it, right? So that's most software development is done in a for-profit type of environment. So that's why people build software, is to make money off of it usually. Avoiding the long-term costs of technical debt also has to do with money. Okay, so if people are forward thinking, they realize that having technical debt will cost them money in the future. And then there are different ways to make upfront investments about applying the amount of money you have upfront. There are different choices to be made about how to apply that to have the long-term payoff. And all of these weigh short-term benefits against long-term costs. Okay, and I got to thinking about it. Most decisions do involve short-term benefits and long-term costs, don't they? And here's a question for you that you can put something in the chat. Do you think that all decisions require a choice between short-term benefits and long-term costs? So I'll give you an example. So last night after dinner, I had to make a decision about whether or not to have dessert, right? There were some cookies and some cake that looked really good. I could eat them or not. Definitely a short-term versus long-term thing. Short-term, if I ate the cookies, I would be happier. It would taste really good. Long-term, I'd have to deal with the calories, right? I'd have to burn them off somehow. So I feel like we all make these decisions in our daily lives all the time, and they all boil down to short-term benefits versus long-term costs. So if you can think of other examples, or if you can think of a counterexample, some sort of decision that doesn't have to do with short-term versus long-term, let me know in the chat, okay? All right. So let's go back. So we've talked about software engineering in general, different types of decisions made in a software project. Now I want to go back to technical debt decision-making and go back to those things that we've learned from recent research in technical debt decision-making. Okay, we learned that there were these three types of technical debt decisions: decisions to incur technical debt or not, decision to pay off technical debt or not, or decision to prevent technical debt or not. Okay, the cost-benefit approach. So some of the reasons that the simplest sort of cost-benefit approach, where you take the cost of paying back technical debt is the principal, and the benefit of paying it off is avoiding the interest payments. So you look at principal versus interest. You try to estimate them. You try to put numbers on them so you can compare them. And that's the simple approach, a simple cost-benefit approach to decisions about paying off technical debt. But this is really, really hard in software projects. There's a lot of uncertainty. Interest is uncertain. When you go to the bank and you take out a loan, you take on debt, you know exactly how much money you're going to get. You know exactly how much interest you're going to have to pay and when you're going to have to pay that interest. It's all written out up front. Not so true with technical debt. A lot of uncertainty. You don't know if you're taking on technical debt and you make one part of the software harder to work with. It doesn't really matter if you're never going to have to make changes to that software, or if you're going to replace that class or that module with something else. So there's a lot of uncertainty, especially about the interest. Even the principal sometimes is uncertain and hard to work out. So there's a lot of uncertainty that makes a simple cost-benefit approach not really work very well. There are also relationships and dependencies between technical debt items. So one technical debt item might be much cheaper to pay off if you're already paying off this other technical debt item. Or sometimes paying off one technical debt item automatically pays off another. But sometimes paying off a technical debt item actually creates more technical debt. If you have a technical debt item that's paid off by refactoring, for example, you have a module that's got tons of technical debt in it, really messy, really ugly. So you refactor the whole thing. That might solve a number of different problems, a number of different technical debt items. So there's all these relationships and dependencies. So applying a simple cost-benefit analysis might not work very well. Also, when you're talking about interest, you have to set a time element, because it's a certain amount of interest per release or per year or per month. So how long do you set your horizon? Do you want to balance the principal versus the interest over the next year? Do you want to balance the principal over the interest over the next release, the next 5 releases, the next 2 years? What's the right time element? And that's kind of a shot in the dark. That's hard to do. So anyway, as I mentioned before, Yupa and I did a case study where we tried to apply a simple cost-benefit approach to a real software development project. And it was really, really difficult. In the end, the project team basically chose the technical debt items that they felt the most strongly about. It was still a gut feeling. They sort of abandoned the trying to quantify the principal and interest. It was just too hard. And then in the end, the project got canceled anyway, so it didn't matter. And that's an extreme type of uncertainty, right? Okay. Some main decision factors at play. So when various studies have asked practitioners to tell us about a time when they made a decision about technical debt. And then we asked them, what were the decision factors? Why did you make that decision? A big one was cost, of course, the cost of paying off the debt, or the cost that would be saved by incurring debt, cost usually in terms of effort and resources. Expected changes, which was a big one. So usually when you're making a decision about a particular technical debt instance or item, you're looking at a particular part of the software, particular module, class, subsystem, some limited part of the software. And a big decision factor is whether or not the project thinks that they're going to be making changes to that part of the software in the future. Okay, so that has to do with what are the new features that are going to be requested in the future, what defects are going to have to be fixed, what parts of the software are going to have to be adapted to new environments later. And all of those have an effect on what you think, how much you think you're going to have to change that part of the software. So if it's a part of the software that you think is going to be changed a lot, it makes sense to pay off technical debt, okay? If it's a piece of software that probably will not ever be touched again, then it's okay to incur some technical debt. Okay, so that was a big decision factor. Time pressure is another big one. How soon do we have to get this release out the door? Okay, it's okay to incur technical debt, to take on more technical debt if that's what you need to do to get the release done on time. Risk, what are the risks? Okay, so, and this goes both ways. If you take on technical debt, there's a risk that it never gets paid off and a risk that it will cause big problems later on. But also if you pay off technical debt, especially if the paying off technical debt involves refactoring, there's a risk that you're actually going to introduce defects and more technical debt, especially if it's a big refactoring. So risk gets in there. Available resources. So this isn't just having enough people to pay off the debt, or it's not about enough people, it's about having the right people. Again, back to the refactoring example, if you decide that it's really important to refactor a particular module, you still might not be able to do it because the person with the expertise to refactor it maybe is not available, has left or is doing something else. So having the right people available is also a decision factor. So these studies that have happened in the last few years have identified these main decision factors. So we have a sense of what they are, which is nice. This visibility to the customer. Go ahead.
We have a comment here about the payoff that you asked previously. It's from Andre Portela. He says, I think that one potential payoff of explicit management of technical debt could be maintaining the delivery frequency, whatever it may already be. So you don't slow down over time.
Mm-hmm. That's true. That's true. So, but the important part there is over time. So paying off the technical debt is an investment, right, in being able to maintain your speed later. And the price you pay for that is maybe slowing it down right now in the current release. That's very true. And that has to do with sustainability, right? Sustaining, getting products and new versions out to your customers over time at a reasonable rate. That's a good point. Thank you.
Okay. We have also two questions. I don't know if you want to answer now at the end.
Let me finish this slide and then we'll go back to those two. Don't let me forget. Okay. All right. So, okay, the visibility to the customer. So technical debt is more likely to be paid off if it's visible to the customer. Now you remember I said earlier, when I gave you the definition of technical debt, I said that technical debt is always invisible to the customer or to the user, right? So at first, this didn't make sense to us, this finding, but I realized that it's a little bit fuzzy, okay? What this means in some cases is that technical debt is not paid off until it actually becomes a defect, okay? A defect being something that's visible to the customer. So there's sort of this fuzzy period of time when there's a thing. Is it technical debt or is it a defect? And that line isn't always really clear. It's a little bit fuzzy. And sometimes what happens is the technical debt item, it's not yet visible to the customer, but they know it will be soon. For example, sometimes there are technical debt items that are affecting the performance of a product. It's slowing down its runtime speed. And maybe customers haven't noticed yet, but they will. Okay, so then it's not quite visible to the customer yet, but it soon will be. In those kinds of situations, the technical debt is very likely to be paid off. So people, even though technical debt is supposed to have nothing to do with the user or customer, decisions about paying off TD do have the customer in mind in many cases. Okay, building technical debt repayment into the process does help a lot. Okay, and there are two ways that we've seen in the literature that this happens. There are things, refactoring Fridays. It doesn't have to be Friday, or it might even be one day a month or 1 week a month, or the point is that it's some period of time set aside every single week or month or release or sprint or something, where developers are given time to just improve the code. They don't have to fix any defects. They don't have to write new code. They don't have to work on any features. They just do things that they know will help make future changes easier. And refactoring is a big one, but there are other things they could do besides refactoring. Could be documentation, could be testing. It's just to catch up. So that's one way. And that way, you don't have to make a decision for each single item about whether to do it or not, whether to take time to pay off that item. You know, it'll be done in these periods of time that are set aside for technical debt repayment. So that's one way. Another one is a rule that we found in a couple of projects, that they have this general rule for developers, is that anytime a developer touches the code, they have to leave it cleaner than they found it. We sometimes call this the Boy Scout rule. So the Boy Scouts have this rule that when you go into the forest or in the woods or in a trail, you always leave it cleaner than you left it. You know, if you find litter, you pick it up. If you find garbage, you pick it up. And you never leave your own trash behind. So this is the idea that developers are expected to clean up the code that they're working on, which means paying off technical debt. Okay, so that they pay off technical debt anytime they touch a piece of software. So these are things, again, that leaves a lot less technical debt that you actually have to make decisions about. So this isn't about making decisions, it's about avoiding decisions, but it works. Okay, and again, TD decision-making is highly context dependent, and it just is. It's a lot of different areas of context, in particular, the relationship with the customer. Okay, so you see differences when you're looking at a startup. Startups who don't have customers yet, but want to get customers, make different decisions about technical debt. You know, as opposed to large organizations who build big systems for government or for other large organizations. Versus internal software development. So an IT department in an organization who's writing software for customers internal to the same organization. There's a different business model there because they're not actually getting paid for it. So the relationship with the customer has a lot to do with how decisions are made about technical debt. The availability of resources, how well resourced the project is, what kinds of expertise is available. All these kinds of things are context dependent. Okay, so that's what we've learned. Let's see. Okay, I'm going to stop here for a minute. Let's first, how about we first take a 5-minute break? Let's do that. And then we'll come back and we'll start with those questions, okay? So 5-minute break, everybody. I will be back in 5 minutes, okay? Thank you.
Okay, thank you, Carolyn.
Okay, thank you.